afternoon, everybody out there in internet land. My name is Josh, and I have the special privilege of being your pilot, let's call it, for our virtual tour of outer space. This is a really fun opportunity for us to use our software that we use in our planetarium called OpenSpace, and to do a show that is basically audience request. If you've got someplace in our solar system or beyond that you think would be an amazing place for us to visit today, by all means, please throw it in our comments. My producer, Mary, is behind the scenes, and she will let me know if there's a suggestion she thinks I can get us to. She's pretty aware of the software herself. So for this presentation, we are, again, going to be using OpenSpace. If this is something you think is super cool and you want to try out, by all means, go and download OpenSpace yourself. It is a really awesome opportunity for us to be able to do some solar system and universe, let's call it, exploring. So I decided we were going to start off with something that I know a lot of people have been thinking about a lot this week, which is the planet Saturn. Why have we been thinking about Saturn so much? Well, we just had what was called a conjunction, where Saturn and Jupiter are visible in the same part of the sky. And if you missed it and you're kicking yourself, I can't believe I missed this thing, and it's not going to be like that for another 800 years, or something. I don't exactly remember how long it's going to be. Well, don't, because these objects are still very nearby. It's a little cloudy here in South San Francisco where I live, but it might be clear where you are, and looking at them close together in the sky is pretty much the same thing we saw a couple days ago. They were just at their absolute extreme closest between Jupiter and Saturn. And as a friend of mine pointed out, it's kind of cool to think that even though they are close together in the sky, they're still about 500 million miles apart. So it's not like these two objects were pulling on each other or changing each other in any way. We just saw them nearby from our perspective. So in our solar system, we get to see our planets as they travel around the sun, and we get to see them line up, get closer together, get farther apart, because we are all moving around our star, the sun, which is kind of a cool and awesome thing. In order to give us a little bit of a sense of scale, I'm going to bring in these blue lines, which show us exactly where the planets are in their orbits. Each planet is sort of leading that part. And just by looking at where we see Saturn right there and Jupiter right here, you can kind of figure out where Earth is. Just draw a line connecting them, and we're right there, third planet from the sun. So as we all move through the solar system, you can see different alignments as we travel. All these objects are moving, and from time to time, things that are moving will seem to line up. But in terms of rare, cosmic, celestial, wonderful events, it's just something that looks cool. It shouldn't have too big an effect on life here on planet Earth, because all these objects, as big and as amazing as they are very distant from us. The force they would affect us primarily through is gravity, and gravity changes with distance, so it becomes very weak at huge distances. Now, Jupiter and Saturn do still have a slight effect on planet Earth, but minuscule compared to the big things that are closer by, like the moon has the tidal influence on our planet, and our sun has a huge influence here on planet Earth. That's actually kind of what I wanted to talk to you about today, is because the 21st wasn't just special because we had our grand conjunction. It was also special because it was the solstice. Now, the solstice is the very special night here on planet Earth, where in the northern hemisphere, we have the longest night and the shortest day. And down in the southern hemisphere, they have the longest day and shortest night. How is this possible? Earth's a sphere. We're pretty close to it. And because of that, one side of our planet is facing towards the sun, receiving more energy from the sun. The other side is facing away. Now, you might notice it looks like half of our planet got a fresh coat of blue paint, and every bit of land has disappeared. That's because I believe I set this up for today, and we haven't finished taking a picture of the entirety of planet Earth. We do see lights of our own North America way up here. I know we had some viewers tuning in from Calcutta over here in India. Pardon me, flew a little too far. So it's probably just beginning to become morning over there, and it's going to be the sun rising, whereas the sun is rapidly setting over here in North America. But because our planet is a sphere, we always get about the same amount of light from our sun. It just changes where it hits. So up in the northern hemisphere, the sun is very low in the sky. We have chilly, short days and long, cold nights. Down here in the southern hemisphere, they have long, warm days and short, warm nights. I know for Australia, one of my favorite artists often talks about how we think of snow and hot chocolate as the traditional Christmas drinks. He thinks of white wine on an afternoon as the appropriate drink to have around Christmas. Here on our spherical planet, People celebrate some pretty awesome holidays in some pretty amazing ways. So when we talk about the other planets, probably many fewer people celebrating holidays there, but still pretty awesome places to visit. I'm interested to know if there's any spots in our solar system people would like us to head to next. But in the meantime, before we see any of those suggestions, I'm going to take us to something that does have a pretty big influence on our planet, which is, of course, our moon. I'm going to take off these trails just to give us a little bit cleaner view. This is going to be a short trip. We're traveling from Earth to the moon, which is only 250,000 miles. It takes astronauts a while to get there, about 3.5 days. But that's on board a very fast rocket. For us, a couple seconds. We are looking down here onto the surface of the moon. We can see about where our Apollo 11 spacecraft landed on the surface of the moon. Always a cool spot to check out. And something we were able to do last Friday with one of the brains behind OpenSpace was really do some up-close visits to the lunar surface. That's something I would always encourage people to do because the moon is just absolutely beautiful on any scale you observe it on. And even though Jupiter and Saturn were stealing the show for the past few nights, the moon has been beautiful as well. On our cool, crisp winter nights here in the Northern Hemisphere, you really do get a chance to see the moon in amazing detail. So if any of you have binoculars or telescopes that you hauled out to go see Jupiter and Saturn, don't forget to turn them to the moon as well. Even Mars, you get to see some nice details there on the surface. I love finding weird features on the moon. It's one of my favorite things to do in the software. If you look around here, you can see these bizarre kind of talon-shaped mountain ranges. What's going on there? This is probably the wall of a crater, but the crater has been filled in with lava long ago and kind of flattened out the base of it. Now, these dark regions of the moon, we call the mare, or the oceans of the moon. They were liquid at one point, but they were liquid rock, not liquid water. And this liquid rock has changed as it cooled and hardened and maybe even been shaped by later flowing lava across the surface. Check out these long, I think these are sinuous rills. This looks like a lava tube up here. But these are cracks and changes in the rocky surface of the moon that we see illustrating its active past. The moon is just beautiful. I could spend all day looking at different craters. The slope changes so dramatically, the size of the crater, the morphology of it. But I see there's some great suggestions popping up in the chat. People want to go check out some other rocky objects. I think that sounds like a lovely idea. Let's start with Venus. Okay, so heading out to Venus, it's going to be a longer trip. Human beings have traveled from Earth to the moon. Human beings have never traveled to Venus. Why is that? A huge omission on our part? Well, it's more to protect our astronauts. Traveling to Venus would not be a pleasant trip for the spacecraft, for the astronauts, for pretty much anybody involved. However, we have sent spacecraft to go visit Venus, to take radar imagery of the surface and to send it back to us here on planet Earth. We use radar because optical just wouldn't work in the same way. When we have spacecraft traveling around Earth, they can use the same color light we see to show us what human eyes would see far above the surface of our planet. This is effectively, there's a couple interesting visual artifacts here, but this is effectively what we'd see if a human being was in orbit around Venus. You'd see clouds, and that's pretty much it. We can't see even a crack in those clouds and a little bit of surface poking out because the atmosphere of Venus is so much thicker and is made of different materials, different elements than our own atmosphere. So it's opaque to our eyes. But using radar, we can bounce radio waves off the surface and see what reflects back. And that allows us to get a view of what's going on the surface of Venus. As some folks have mentioned in the chat, Krishna mentioned this is hot. Absolutely. This is a place that is hot enough to melt lead. But as a person who's never really melted lead in my life, that's always kind of an interesting connection. What I can tell you is that if you are a fan of pizza, this is a place to cook pizza in about a minute just on the surface. That's a very hot place because I have stood next to a pizza oven and you can really feel that heat on your face. So in this map, it's not lava. The rock is not liquid and moving around on the surface. It's rock. It's solid. But we can see some interesting volcanic evidence that tells us there may have been some volcanic activity on the surface of Venus not too long ago. Fundamentally, Venus is made of the same boring gray rock as Earth, as Moon, as Mercury, and even as Mars. Yes, you heard that right. even though we often call Mars the red planet, it's really not red. The dust, the outer surface, is reddish because it has iron oxide, a combination of iron and oxygen, which is pretty common on these rocky worlds. But on Mars, it has formed this blowing dust that moves around the surface, giving it that distinctive reddish hue. So when we get to Mars, at first it's just going to look like it crashed, number one, but it didn't. It's loading. And when we look around on the surface, you can see a few features popping out. I see Rajesh asked, when would it have last been volcanic activity on Venus? That is a tough question to answer because I don't think there's scientific consensus. There's a lot of disagreement about whether or not we are still seeing some hint of volcanic activity on the surface of Venus. It's too early to call Venus truly geologically dead, but I would say that we haven't seen too many volcanoes go off in the time we've been observing it up close. So I'm not quite sure. That would be a challenging thing for me to answer confidently, but it is the kind of thing we can look up and at least give you some of the estimates, some of the framework on when it's last gone off. On Mars, we are much more confident saying that it is probably not volcanically active. There's just not stuff happening on Mars. This is a planet that once had amazing volcanoes, but these days, probably not so much. We can see evidence of those volcanic areas, even by doing something very simple called crater counting. Look around here. And if you were to try and guess how many craters we're seeing, you could sit somebody down and have them count, maybe a couple hundred. But then as you look closer, you'll notice what you thought was a big crater is actually a nest of smaller craters. There's probably several thousand in this random chunk of Mars I found. So let's try a different chunk and compare it. If I look up here, would you say there's more craters or less? Now, there are still some small ones to be sure, but looking around here, you can see mostly smooth stuff. There are some craters to be sure, but less than we saw before. What's going on? Well, one of the best arguments we have for Mars being active is the motion of stuff on the surface. If stuff's completely stagnant and still, when something strikes the surface, like an object falling from space, it'll leave a crater behind. This part of Mars is much younger, if you will, than the other surfaces because it has changed more recently. So I often equate the life of a planet to its volcanic activity, but there's lots of ways you could do that. Ultimately, it's all poetic license. Why is Mars' surface this color? Well, this is exactly what I was saying before, iron oxide. So that reddish rust you see. Well, I used to live by the ocean, so I saw it everywhere. If you leave something metal outside your house for 5 minutes, it's going to start rusting. We lost a good grill pit that way. But on Mars, this is probably not forming from rust. It's not water or salt water getting on something to make it rusty. It's iron bonding with oxygen. There is a little bit of oxygen in the CO2 atmosphere of Mars. So one explanation for why some parts of Mars are smoother than others is volcanoes. Another reason might be oceans in the ancient past that have smoothed some of those parts out. We can go visit Olympus Mons. That is the biggest volcano in our solar system. Now, in order to spot it, I think we're going to have to cheat and turn off nighttime on Mars so we can see the entire surface. Looking around here, you can start to see these dark, dark areas. This is the Watney Triangle. If you're a big fan of the books, The Martian, or the movie with, I think it was Matt Damon. There we go. Down here, you can see Valles Marineris, and that means we are heading in the right direction. I see 1, 2, 3 big volcanoes, and then an ultra super big volcano is actually right on the terminator and going to be super hard to see. If we go from the side, you can see that lump right there. That is Olympus Mons. But to give us a good view, I'm going to jump in here, and I'm going to crank time forward ever so slightly by 1 hour. Actually, I'm going to go backwards 2 hours. There we go. That is Olympus Mons. So diving into Olympus Mons, check this out. When we land right by Olympus Mons, you can see just how gigantic this mountain is. There are beautiful shots of the giant volcanoes of Hawaii casting their shadows down into the morning fog surrounding the islands. There's some beautiful things that really give you the three-dimensional nature of these objects. One day, I would love to see a shot similar to that taken from the slopes of Olympus Mons. But to do that, we have to land some of our amazing photographers down on the surface. So I see some discussion here. This looks like a skin blemish on the surface of the planet. I have often equated volcanoes with that, but I'm told that that's gross and I shouldn't say that. But this is huge. If you want to really understand how big it is in terms of height, it's 3 Mount Everests tall. That's gigantic. By any measurement, that is a huge mountain. But to the point made earlier, it's long, not big. Well, it is a very wide feature. So I would dare hazard the supposition that in terms of athletic fitness, you wouldn't need to be quite as in shape to get up the slopes of Olympus Mons, or at the very least, you'd need to be more of an endurance climber, not so much a pulling up your whole weight by your arms. Number one, you'd weigh less on Mars, but number two, it's a very shallow feature. Because it is so wide, you can just kind of walk up the sides, not climb vertically. This is a volcano. So, Rinkesh, this is probably where a gigantic blob of lava was under the surface, forced its way up, and erupted out, creating this gigantic Tharsis plain. It covers a huge portion of Mars. Mars is a smaller planet than Earth, so it's a little bit outsized comparatively. But let me tell you, if you scooped up the entire Tharsis plain, this is about the size of Arizona, and this is the Tharsis. Let me zoom back some more. This whole smooth feature is relatively free of impact. So we think this is one gigantic volcanic plain that unites these 4 megavolcanoes. Now, if you scooped this up and dropped it on planet Earth, it would cover up most of the western United States. So thankfully, we don't have any giant supervolcanoes in the western United States, do we? We do. We actually have the Yellowstone volcano. So maybe this is a sister to the Yellowstone volcano. We would need somebody who knows a lot more about giant planetary volcanoes than me to answer that question definitively. But for me, it's always a little bit daunting to realize that the planet next door had a giant supervolcano go off and it covered a huge amount of its surface. Makes me a little paranoid every time I drive through the middle part of this country. Not that I've done that recently. It's been a while. Okay, I got way too fixated on Mars. I spent like 10 minutes there. Is there any place else in the solar system you would like to go? We had requests for Venus. We had requests. Oh, I saw one for Io forever ago, way higher up in the chat. Let me see if I can get us out there. Speaking of volcanoes, this is a real fun connection because it's not just planets that have volcanoes. That's an old view that the only thing that could be planetary geology was planets. Now we have planetary geology happening on moons, which means maybe we shouldn't call it planetary geology. We should just call it geology. Or maybe not even geology, because that still has the word Earth built in there, geo. We need to come up with better terms in astronomy is the takeaway lesson. So looking around on Io, this, you were talking about blemishes. This would be covered in blemishes. Kind of looks like a really gross cheese pizza. Now, looking around on here, you can see icy features. You can see volcanic features. You can see these smeared out red parts where volatiles from deep inside this moon have been blasted onto the surface. This little moon has a ton of active volcanoes. If you want to find out more about Io, there are great resources online. It is an absolutely beautiful place. And man, I hope one day we can send a mission to really just explore Galilean moons and take their time around the moons of Jupiter. Okay, astrospherology. I really like that. That covers a wide variety of bases. I'm a fan, Rob. Next door, we have Jupiter. So let's take a quick gander at Jupiter. We are seeing it from its polar regions, which is very similar to the views we get from Juno. If you are a Jupiter fan, like it seems a whole bunch of folks are in the chat, I'm sorry, Sharon, if you leave a science museum or a science presentation and you're not a little bit freaked out, we haven't done our job. But if you look at Jupiter from these polar regions, you can see some great shots from Juno. Absolutely beautiful images taken from orbit around Jupiter that really give us that coffee and cream combo, that convection, the changing, beautiful, intermeshed surface of this gigantic storm planet. I love seeing these up-close images because it really does just illustrate how much of a wonderful and beautiful painting any shot of Jupiter is. So, can we see any storms bigger than Earth? Well, there is the Great Red Spot, which I think might be what you're thinking of, but I will also point out a lot of these storms, like this little one right here, when I say little, that's got to be maybe Mars-sized. If you look around, you will almost certainly see Earth-sized features popping out too. I would guess that something like this is probably getting close to Earth-sized. Down here, that is definitely an Earth-sized storm. Jupiter is covered in Earth-sized storms because Jupiter is absolutely gargantuan. Now, I'm going to turn off nighttime on Jupiter just like I did on Mars to let us see the entirety of its surface, even the part that's facing away from the sun. And over here, we should be able to spot that great red spot. Get it? Spot, spot. There we go. Now, one of my favorite photos we saw from the conjunction, you can just make out the great red spot on Jupiter and Saturn. That must have been a very long set of exposures. It is always so cool to see features like this, to really get a sense of the weather and changing surface of another world in our own solar system. Just the coolest thing. I love imagining exactly what it would be like to be in orbit around a place like Jupiter, but you'd have to be pretty careful. One of the reasons that Juno is in that funny polar orbit is that it doesn't get cooked. Jupiter has powerful radiation bands around it, so if you got too close to it, it would not be a great day for a human being. Going inside Jupiter, it's a little tough for our software because we base everything you're seeing off actual information, and we don't have a lot of information about what's going on inside Jupiter. That's one of the reasons the Juno mission is working so hard. It really wants to better understand what's going on inside Jupiter's guts, as it were. We know a lot about the outsides. We've been studying it. We've been modeling it and trying to understand, based on what we see changing on the outside, what could be happening inside. We have some models, but one of the biggest parts of the Juno mission is to help confirm which one of those models is correct or where we're getting those models wrong. Now, we know deep inside Jupiter there is hydrogen. We have dropped a probe in there to give us as much information as it could as it fell through the clouds of Jupiter, but you lost contact with that probe pretty quickly because Jupiter, again, is a very hostile environment. Okay, let's see. Where else next? I see some cool suggestions popping up for the outer solar system. Where should we go next, Mary? Let's see Pluto. Excellent. We're going to head way far out in our solar system to go see Pluto. Now, a trip to Pluto could take a long, long, long time because at rocket speeds, we're talking about maybe 10 years to get out there. It took 10 years for the New Horizons spacecraft to get to Pluto, and that was one of the fastest traveling things human beings have ever made. When we get close to Pluto, we can actually see the images it took. Remember what I said before about rocks on Mars, where the more craters you see, the older the surface is? But you can see dramatically different parts of Pluto. This definitely has craters on it, but very few. If you look down here, tons of obvious craters. If you look over on other parts of Pluto, you'll see a huge change as well between lots of craters or absolutely minimal craters. And then there's this weird stuff. If I zoom in on it, you can see it looks swirly. Kind of like, have you ever mixed food coloring in with like a thick, viscous thing? Like maybe frosting? People are doing holiday cookies. If you do, you'll notice that it mixes unevenly. When you've got a less dense thing and a more dense thing mixing together, you often get this kind of distinctive swirl. This is a nitrogen glacier on the surface of Pluto. So to see it a little better, again, I'm going to turn nighttime off. And now we can see this glacier up close. We're going to dive in, and when we do, you will notice it looks completely smooth. There's not a single crater to be seen anywhere on this gigantic feature. We think this giant nitrogen glacier just swallows up impactors. When something falls down and hits the surface, it gloops through, gloop being the technical term, and then covers up whatever impact site there was. Now, because of that, this is an entirely fresh, new surface. There just isn't change on that same kind of cratering scale. You can see some of these other places where it looks like maybe material is flowing downhill. I've never noticed that before. That is really cool looking. And there's a lot more mixing happening right down here. One of the things I like best about software like this is that you will see things that you've never noticed before every single time you do it. But because there are scientists poring over the same data, sometimes they've answered the exact question you come up with. So it's always really nice to look up the latitude and longitude, the position of wherever you see something really weird, and see if someone else is asking the same questions about what you're seeing. So we had a question, is Pluto still a planet? That is a polarizing one, depending on who you ask. The United States Space Agency, NASA, has declared that some people within it think Pluto's a planet. Unfortunately, folks at NASA do not get to make that decision. There is a group called the International Astronomer Union that decides what is a planet. Dwarf planet is the preferred nomenclature from that scientific body, so dwarf planet is what we will call it. But I would offer that dwarf horses are horses. Dwarf galaxies are galaxies. When we talk about a dwarf planet, I think it's more comfortable for me to think of it as a subset of planets, not something different from planets, just a group of planets. So this is a little bit heretical, and I want to emphasize that while I'm saying it. When you talk about a dwarf planet, I think that's kind of like a gas giant or a terrestrial or an ice giant. That should be the kind of planet we think of it as. So if you are interested in finding out more about Pluto, a little bit about some of its surface features, I see a link. Mary wrote an article about Pluto's heart and the nitrogen stuff on the surface. You can find out more there. If you want to find out more about what makes Pluto a planet, there are great videos online. And if you want to do some flying yourself, maybe go visit these objects and learn as much as you can about them, I think OpenSpace would be a really cool thing to download, since there's ample opportunity over the next few weeks. People are going to be spending time at home. Give it a shot. Let us know. But with that, I think we are running a little short on time. I'm going to tilt us back towards Earth. And as I take us back into our own little bright spot in the universe, I would really like to thank all of you for tuning in and joining us here for our virtual tour of outer space. I hope that I've inspired you to maybe check out some software like OpenSpace. Let us know what you think. If you have decided you don't want to explore yourself, but you want to point us in the direction of something really cool, I see some great suggestions popping up in the chat. By all means, tune in next week and let us know where we should be going. We will be broadcasting next week on the, 30th. So right before the end of this year, tune in, let us know where we should be heading, and kiss 2020 goodbye with us in a really fun way. But with that, again, thank you all for joining us for our virtual tour of outer space. Stay home, stay happy, stay healthy. We are going to keep broadcasting until we are able to reopen our dome. But on behalf of myself, Morrison Planetarium, and the OpenSpace team at the American Museum of Natural History, thank you for joining us and have a wonderful rest of your day.